Stand up for the law. Stand up for decency. Stand up for compassion. Stand up for respect. Stand up for your community. Stand up for your future. Stand up for South Africa. LeadSA.co.za.
We like helping people who've helped themselves. So do our listeners.
Entrepreneurs SA on Talk Radio 702 and 567 Cape Talk.
With FNB.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
Okay, Chris, I'm very curious about you. I have an aversion to digital clutter. I just feel that there's just too much communication, too much accessibility. There's no solitude and silence. That's why I'm not on Facebook and Twitter. I'm curious about your Twitter and Facebook habits. Chris, what are they?
Well, I'm pretty similar to you, Reedy, actually. You'll probably be pleased to hear. I purposefully have not bought a smart telephone so that I can't access the internet from my phone.
Yeah.
I do have a Naked Scientist Twitter account, and we do have a Naked Scientist Facebook account, but that's because it makes it much easier for people who want to ask us things and get in touch with us to contact us, in the same way that any radio station or communicator has a channel for people to contact them. But I don't really use my personal stuff that much, for the very reason that you say, because if you're not careful, you end up with work time encroaching into home time, and you basically end up, even though you've gone home from work, you're still at work, and it's very, very tempting when you go on holiday to read your emails and then respond to a few things, and you never really switch off anymore. So I'm trying, my goal for my next 12 months of life is to try to have a better work-life balance by eschewing these kind of technologies, except where they're necessary and helpful. Because at the same time, they are really good, because it means that you can reach whole new groups of audiences, people can get in touch with you much more easily. There are people who may feel intimidated or inhibited about picking up a telephone and calling a radio station,
sure,
but they will send an email and so on. So I think these things have their place, and I think they're good, but when they're used in the right way.
Absolutely. All right, let's talk about this gene therapy for depression. What's that about?
Well, this is interesting. We know that depression is very, very common. In fact, if you look at the population in general, you will find that roughly 1 person in 5 at any one time has symptoms of depression. And a smaller minority, perhaps 1 to 2% at any time, have clinical depression, which is where the depression severely affects them. And many of these depressions will respond to a group of drugs. There are lots of very successful, very effective antidepressants around now. But there are some people who don't. And there are some people who get such severe depression that it totally destroys their life. And if we could find a way to help those people, then we could dramatically change their lives. And what scientists have been investigating recently is whether gene therapy may be able to help. There's a paper in the journal Science Translational Medicine this week. It's by Brian Alexander and his colleagues. They're based at Cornell Medical College in America. And they have presented data showing that in mice, you can trigger or increase the activity of a gene called P11 in one part of the brain, a part of the brain called the nucleus accumbens, which is the brain's pleasure center. And if you increase the activity of this gene, P11 there, you can turn depressed mice into happy mice. So what's the background to this story? Well, people have found that in humans with depression, you find low levels of activity of this P11 gene in the nucleus accumbens in humans. And if you take a mouse and use genetic engineering techniques to remove this gene from the mouse, the mice do show classic signs of depression. So therefore, putting the gene back into this bit of the brain selectively seems to be able to offset the depressive effect. And the way the gene works is that it helps cells, nerve cells, to put onto their surfaces receptors, chemical docking stations for nerve transmitter chemicals. And so it seems that it makes nerve cells more sensitive to one of the brain's feel-good hormones called 5-hydroxytryptamine or serotonin. And that's probably how it's working. Now, there are 2 trials, a number of trials, which are currently underway to add genes to the brain in other conditions, things like Parkinson's disease. And so what these researchers are suggesting is that as we're already doing clinical trials for Parkinson's disease, it would be very easy to also do some trials in people with very severe depression and use the same technique for getting the genes in for Parkinson's as getting this gene in for depression. So watch this space.
And then the oldest galaxy ever, a team of astronomers finding this?
Well, this really is an example of looking back further than anyone has seen before. There's a paper in Nature this week. It's by researchers in France. It's Matt Leynard and his colleagues, who are at the University of Paris Diderot. And what they have done is to report seeing further back in time than ever before. They're seeing a galaxy that was in existence 13 billion years ago. This came about because they started using the Very Large Telescope, which is a European telescope operation down in Chile. And they were looking at a patch of the sky called the Hubble Ultra Deep Field, which is a part of the sky which was first examined by the Hubble Space Telescope. People knew there were distant galaxies and things there. So this team used an instrument on this Very Large Telescope in Chile to do an extensive analysis of this bit of the sky. And they were able to pick up light coming to us from this galaxy. It's called UDFY 38135539, catchy name. And what this light reveals is that it's been traveling for over 13 billion years to get to us. And why this is important is that it sheds new light, if you excuse the pun, on what the structure of the early universe was like. Because the early universe, or the universe when this galaxy was knocking around, was only about 600 million years old. It's now 13.7 billion years old. So it was very, very young. And this was one of the first galaxies to form. And what it was doing was clearing this smog of hydrogen, which pervaded the early universe and was produced by the Big Bang. And this was what's called the reionization era, when ultraviolet and ionizing rays from these bright stars in these early galaxies helped to break apart those hydrogen atoms and make the universe become clear so we could see through it again. And understanding how it cleared in that way and what the early structure of it was like is very important to our modeling of what happened immediately after the Big Bang and how the universe became how it is today.
Wonderful. All right, let's take your calls on 021 446 0567, 011 883 0702, 31702 if you wish to send your questions via SMS, and 31567. Let's go straight to Robert in Alberton. Hi.
Good morning. How are you?
Fine, thanks.
Good. The other day, my daughter and myself were watching CBeebies. Now, they took a 2-liter bottle of water. Well, they took a 2-liter bottle, filled it up with water, punched a hole in it, put the lid on, and the water did not come out. Now, I want to know how that works, and if you have to punch 2 or 3 holes in it, will it work as well?
Hello, Robert. You can do a similar experiment. If you take a glass of water, stretch a handkerchief, obviously something which is fabric material, so something like a handkerchief, over the top, put an elastic band around it to hold it over the top of a glass, for example, and then turn the glass of water upside down. Now, you'd think, because if you dip a hanky into water, it just soaks up water and the water runs through, you would think all the water would come straight out of the glass. It doesn't. The hanky, despite being gas permeable, will not let air into the glass, and therefore the water stays in the glass. The reason the water stays in the glass is that to fall out, you would end up with a vacuum above the liquid unless some gas goes in to replace the liquid that's been lost and enabling it to fall out. Why does this happen? Well, the reason is that with a hanky, and probably also with your bottle with a very small hole and the lid on, the bubbles of gas that would form as they went through that tiny hole or through the matrix of the hanky would be so small that the collapsing pressure, because of surface tension of water, would prevent them from forming. What I mean by that is water is very sticky, and it has this property called surface tension, which is where all the water molecules are pulling on each other and trying to get themselves as close to each other as they can. So to form a bubble in water of a gas is very difficult, and small bubbles are collapsed down very hard by the water. And the effort of air trying to get in through the hanky or through your tiny hole in your bottle is so great that the surface tension of the water stops the bubbles from forming in the first place, so the water can't come out. If you take the lid off the bottle, or if you do in your hanky experiment, you peel back the hanky a little bit and let a bubble of air go in, the effect breaks down and the water comes out normally.
All right, and we go from that to Debocho's question. Debocho in Rodipuert. Hi.
Hi, Riri. How are you?
Fine, thanks, Debocho.
Great show. Hi.
Thank you.
I wanted to find out, in terms of child's brain development, once they have done their nappies stage and then they go into taking the panties and the underwear, parents normally wake them up during the evening just to take them to the loo to prevent wetting. So how does that affect their brain development?
Okay,
regularly waking them up?
Okay, all right.
I don't know, but I hope it doesn't affect them adversely, because I do exactly that with my daughter. We get her up and put her on the loo, and much to her chagrin, at about midnight. And it's like Jekyll and Hyde, because she'll go to bed, this delightful child, and then when you wake her up in the middle of the night and go, do you want to come for a wee? She goes nuts. But, I don't think it makes a major problem. I think that your brain is a very plastic organ. In other words, it's changing all the time based on your experiences. And so I think that the human brain is so amazing anyway that it's not going to be adversely affected by getting you up to go for a wee. So I think you're probably all right. I hope it's all right, because that's exactly what I'm doing.
Yeah, good. Keep going, Debucho. Keep doing that. Otherwise, you'll be washing some sheets the next morning, and that is very unpleasant. Lewu in Kempton Park, hi.
Hi, good morning. My question is, I'm an adult. I'm not able to take tablets. And now I have to crush my tablets and then dissolve in water and swallow. So now, and also now I've been prescribed liquid capsules. I'm not able to swallow that either. So now I've been advised I can just prick it and then drink it in a liquid form. My question is, does that make any difference how you take your tablets?
Okay, whether you crush them.
Very good question. Hello. The answer is it depends on what's in the capsules or in the tablets. Now, simple tablets and simple liquid capsule formulations, where it's literally just usually a gelatin bag surrounding the capsule with the drug mixed in with some kind of carrier or liquid inside, those are usually fine, because all that happens is when you swallow them down, the stomach acid and the digestive juices break down the gelatin coating, the drug comes out, and then it gets absorbed in your intestine. But other forms of tablets and capsules are a bit more intelligent or a bit cleverer. And the way they work is that they may have coatings of different thicknesses around the things inside the tablet, so that the contents dissolve at different rates as they transit through the intestine and are therefore absorbed more slowly. In other words, rather than getting a huge surge in the drug all at once in one place in the intestine, they're designed to slow release by releasing a small amount of the drug at different points. If you take one of those tablets and grind it up, you can totally offset that effect. So the answer is, if you've been told by the person who's the pharmacist or the doctor that that's okay to break open the tablet because it's a simple medication that doesn't use that kind of technique, it should be fine. But if it's one of these more intelligent, usually they're sort of gastro-friendly type things, which may have something which is a bit corrosive to the stomach in the drug, and so they coat it with something to make it stomach-friendly so it gets beyond the stomach before it's absorbed. If it's that kind of preparation, you should be a bit careful. So it's definitely worth discussing it with a pharmacist who can look up what the medication is, what the formulation is, and therefore if it would be adversely affected by grinding it up.
We have an SMS here. What are freckles and how do they form?
Well, freckles are the preserve usually of people with very pale skin, and they're usually much more common in people who have pale skin and red hair, although anyone can get them. They're patches of pigmentation. Pigmentation in the skin is caused by melanin, and melanin is produced by cell types called melanocytes, which are resident in the skin, and they, in response to a hormone called melanocyte-stimulating hormone, they become more metabolically active. They make more of this melanin chemical, which they then add to the skin, which makes the skin darken, and the role of melanin is to absorb ultraviolet rays, which protects the skin from ultraviolet damage, and it also stops you losing your folic acid in the skin, which is why people who, when humans first evolved in Africa, they evolved to have dark skin, because that way the sunlight wouldn't damage their skin and render them folate deficient. When people with light skin get a lot of sun, in some people you can get these little patches of focal melanization, which are these little freckle spots, and they'll tend to therefore become more exaggerated in the sun. And when people are exposed to a British climate where the sun is something you don't see for 90% of the year, then they tend to go away.
And another SMS, what is the highest count in beats per minute that the human heart can reach? In other words, the highest ceiling. Is there a point or count where the strain on the heart becomes so much that it simply gives in or stops working? That's an SMS.
Well, the human heart is an amazing organ. It beats billions of times in a lifetime. The average for a healthy adult is about 70. A trained adult, 60, a very well-trained, fit adult who would include the referees running around in the stadia at the World Cup in South Africa this year, they would have had a heart rate when they were resting of about 40. When they're exercising hard, a very fit person, paradoxically, has a lower maximum heart rate than someone who is unfit. And so someone who's unfit might manage a heart rate as an adult of 160. Someone who's very fit might only manage 150 or 140. And you might say, well, why would a very fit person have a lower heart rate? And the reason is that with training and becoming fitter, the heart gets larger and more muscular and can pump more blood with each beat. But because it's larger, it takes longer to fill it up. Mm-hmm. And so in order to remain efficient as a pump, the heart has to actually operate more slowly, but it's actually working a lot better because it's pumping more blood with every beat, therefore doesn't have to pump so often, and that's why the maximum heart rate of someone who's well trained is a bit lower. If you flog the heart too hard and you push the rate up too fast, there is a risk of something called an arrhythmia or a dysrhythmia happening. Mm-hmm. And this is where the heart becomes electrically unstable, because the beat of the heart is an electrical rhythm which originates in the heart itself. The muscle cells that make up the heart are electrically active, so the cells become what are called depolarized. They leak small amounts of sodium into each of the heart cells. This makes the cell become excited, and it then beats once certain amounts of sodium get into it, and it propagates that beat onto the cell next door to it, so the whole heart then beats in synchrony. If you end up with the heart going too fast, sometimes the conduction of those beats across the heart can go out of phase, or they can begin to spread in an irregular way, and the heart therefore begins to beat erratically, and that can cause a person to die. So in some people who have a tendency to develop these arrhythmias, it can be fatal to flog the heart too hard, and elderly people are more prone than younger people. But on the whole, it's an amazing organ which works incredibly well for many people for 80 to 100 years.
Thank goodness for that. Claire in Weinberg, hi.
Hello there. I wanted to find out from Chris if he could define the problem of TGA, transient global amnesia.
TGA, transient global amnesia. What's that, Chris?
Well, transient global amnesia is a problem that some people who are psychiatrists will occasionally say that patients present with. Doctors will occasionally see patients who say that they suddenly wake up or they suddenly appear somewhere and they cannot recall anything that's happened to them. I don't know why this happens. I'm not sure whether it's down to certain people having a tendency to this, or whether it's more common in people with an underlying psychiatric problem, or whether it can be caused by drugs and things. I suspect all of those things are probably true, but it's where people just suddenly have absolutely no memory of where they've been, who they are, and what they've done.
Doesn't sound pleasant at all. Klaus in Roodepoort, hi.
Hello. Good morning. Chris, I've had a cataract operation a few years ago. Now, as I understood, the original lens in the eye is contracting and expanding to allow focusing on nearby and faraway objects. Is that correct?
Yes, that's right. The lens is actually in a little capsule inside the front of the eye and has muscles called ciliary muscles connected to it, which can either stretch or allow it to be compressed, and this changes the thickness, and this does a focusing job.
Okay, now, after the cataract, I got lenses in which don't do that. But I'm still able to focus nearby and far away as good as I could previously. How does that work?
Well, actually, although people think of the lens as doing the most important job in the eye, in fact, the vast majority of the focusing of light in your eye is done by your cornea, the tissue on the front of the eyeball. And so, actually, the lens makes a more minor contribution. And so what they do when they give you a cataract operation is to remove the original nucleus, the lens nucleus, which has become fogged. And this occurs for a variety of reasons. Ultraviolet exposure, various metabolic conditions can do this. It's hereditary. Age is also a risk factor. And the material that makes up the lens just becomes smoky and foggy. And so it tends to distort the light that comes through, makes night driving and night vision very poor. It means that people see various other optical phenomena which are caused by the light scattering across the lens, and it destroys acuity and appreciation of colour. Mm-hmm. And so they will degrade that lens nucleus and replace it with a prosthesis. So you put a little replacement lens into the pouch, the membranes that would have held the original lens, and that is held in on two little wiry pieces which are like springs, which spring into place and hold it in place. And so the light then comes in and is focused by that lens, which is put in because when they do the operation, the ophthalmologist will look at what the refractive index of or the focusing behavior of your eye is normally, so they can then work out what they need to put in there as the prosthesis in order to give you good vision. And they'll put that prosthesis in, and then hopefully your vision is A1 again.
All right, Klaus, thank you very much for asking that question. We get a lot of that via SMS, and I do believe we've answered it previously. Mark and Stuart, stay on the line. We're back after this.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
Let's go to Mark in Sandton. Hi there, Mark.
Hi, good morning, Reedy. Chris, thanks for taking my call. I don't think this is a common problem, but growing up we used to have house flies that were quite small, but lately they've been quite huge. It's mostly in the Johannesburg area. I haven't seen them in Cape Town. Is there any reason why this phenomenon?
Okay, flies are getting bigger.
Hello, Mark. Well, flies need stuff to eat, and the more there is for them to eat, the more that they're going to grow, and the more of them there will be. The small flies that you tend to see tend to be fruit flies, Drosophila, and they like eating bits of fruit, not surprisingly, and you'll find they're attracted to your nice, beautiful South African Shiraz. They love red wine. The vapours and the volatiles that come off are very similar and include some of the same chemicals given off by fruit that's breaking down on the ground that the flies love to come and eat. So they'll be attracted. But if you've now got rubbish tips and things, or if there's a new waste disposal unit opened or something, which will sustain these much bigger flies that are not fruit flies, they like eating other mouldy things and heaps of rotting meat and all this kind of stuff. If there's a new waste disposal facility opened, or there's been a lot of rubbish that's not been dealt with properly, you will get more of these kind of flies. Sometimes it can be something as trivial as a warm winter, which doesn't knock them all off, and so more of them survive the winter and lay more eggs, and there are more of them the next year. So it might be something like that. So a combination of more food and then ideal weather conditions and the right sort of level of dampness and dryness, which has enabled the flies to breed.
Yuck. Stuart in Ferndale, hi.
Yes, good morning. Thank you, Judy and Chris, for taking the call. I'd like to know whether the moon has an effect upon the Earth, its gravitational pull, and how it affects the Earth. And if there is an effect, is this not because of design rather than chance?
Hello, Stuart. Lots of questions there. First of all, where does the moon come from? Well, the moon came from a collision between Earth and a Mars-sized planet roughly about 4.57 billion years ago when the Earth was just forming. So these two planets collided. They merged into one and ejected huge amounts of material, largely Earth's crust material, up into orbit around the Earth. And it then, over the next few million years, coalesced to form this body, which is the moon, which we have today. That's why Earth has a disproportionately big moon. The moon is very, very useful because having this large gravitationally active object near to the Earth, it stabilizes the Earth, which means that rather than our Earth having this very, very big departures from its axis, in other words, tipping over a lot, because the Earth would otherwise precess and tip over on its axis, and this would cause all kinds of dramatic weather. The moon has a stabilizing effect on the spin of the Earth, and so it keeps our obliquity very, very stable, and this is probably why the Earth is such a propitious environment for life in the first place. The moon is pretty close to the Earth, 100 million miles or so, and it's not as far as that. That's the sun. It's about 300,000 kilometers to the moon, so it's very, very close. So the gravity from the moon has a direct effect on the Earth's spin, but also on the tides. And the reason we have two tides a day is because the moon is attracting water on the surface of the Earth closest to it towards itself, and then on the opposite side of the Earth, the water there is being less attracted, and so you get a bulge there as well, which is why you get two tides a day. And so those are the two effects that the moon has on the Earth.
Geez, and all this time I thought it was merely there to contribute to romantic evenings, Chris.
Well, it does that too, but the question was about gravity. I suppose you could say gravity is an attraction, and it could be an attraction between two people if one of them's sufficiently fat. But, and that wouldn't apply to you, of course, or me. But, there you go.
You naughty man. Chris, we'll chat to you next week.
Okay, well, thanks for having me. See you next time.
Bye. That's Chris Smith, the Naked Scientist. And of course, this will be available as a podcast. Time just flies, and we keep getting more and more questions. We do have your SMSs from last week and this week as well, but unfortunately, we don't get to ask them. And all of them. And by the way, there are some questions that come through that we've dealt with before. And, maybe I remember because I present the show every Friday, and we make a record or keep a record of the things, of the content, and some of the questions just come up. So if you're not hearing your question, it could be because it's been asked before, or it could be there are like 50 more questions before that. So thank you very much for taking part in our conversation. Keep your emails coming, and we'll find a spot for them another time.